Hey guys, this is Ben with Pessler. In this PRTG tutorial, we're talking about SNMP. Okay guys, so now let's talk SNMP. SNMP stands for Simple Network Management Protocol. It's a protocol that's been around for a very long time, and on just about every piece of networking equipment, it's available to use for monitoring different things about the device. It does have an element too where you can actually push configuration to the device, but with PRTG we don't touch that. With PRTG we only ever work with read-only SNMP, meaning that we ask the device questions and we get answers. Never ever will we ever modify the configuration of a device with PRTG. It's something we just don't do. Some of the other things with SNMP that I want to go over: the different versions that it has. So with SNMP we have three different versions. There's SNMP v1, SNMP v2c, and SNMP v3. With SNMP v1, this was the first iteration of it. It's still used by a lot of devices. A lot of legacy devices support only this version. It works just fine, but it is limited to 32-bit counters, meaning that there are some integer values that it won't be able to report if they get too high. Now, SNMP v2c is by far and away the most commonly used version across the planet. Every device that supports v1 will usually support v2c, although there are some exceptions. v2c does have 64-bit counters, so for your interfaces that have really high interface counter numbers, it's not a problem at all. There's also a few extra things that v2c supports in terms of different counter types over version 1. The last one, SNMP v3. SNMP v3 is the answer to security when it comes to SNMP. So with SNMP v3, you have everything you have with SNMP v2c. You have the 64-bit counters, you have all the advanced features, but we add encryption and authentication. The encryption part, you choose how you want the data to be encrypted, and with authentication, you set up users and passwords. It is a little difficult to set up with there being so many different options on so many different devices. It can sometimes be a little bit of a pain to get it up and working. Once it is working, it's great. There is a slight higher bit of overhead with SNMP v3, but that really only comes into play when you've got thousands of sensors. So if you've only got a couple of hundred sensors, but you want them to be secure with SNMP v3, you're not going to notice that much of an overhead difference between v2c and v3. Now, the other part with SNMP and how we actually get the data from the devices, we get that through OIDs and MIBs. Now, what is a MIB and what is an OID? Well, a MIB stands for Management Information Base. A MIB is comprised of OIDs, object identifiers. A MIB is put together by the vendor of a product. They may make it based on the product model, the software version that's running, the whatever different facet they want to classify it by. It's completely up to them as far as how they build out their MIB files. There is a governing body behind it all, and the MIBs are structured, and for that we go here. So this is the this right here is the MIB structure that everything follows. It starts at the root level, and then from there it goes to CCITT, ISO, and then joint ISO CCITT, and then you just follow everything down. You can see there on about the 5th line down where it says Internet 11361. That is where pretty much all of the devices on the internet follow. From there, you've got directory management, experimental, private, security, and then SNMP v2. SNMP v2 you don't see a whole lot of. mostly everything tends to fall in private and management. So after we go from there, this is where you start getting your vendors assigned ID numbers. So you can see here, Cisco is number 9. So Cisco's starting OID structure is always going to be 113614-9. And there's a period between every one of those. After 9, it's completely up to Cisco on how they want to structure their MIB file. They may start over, they may start with some other number. It's completely up to them. From that point forward, it's green grass, all how they want to do it. So the same thing would apply too with management. I don't see that one used as often as I see private used. Private tends to be the more common one that all the vendors follow. Now, in terms of what is a MIB file, well, this right here is a MIB file. A MIB file is a text document that you get from the vendor. Some of them are out in the clear because they're open source. They're RFC documents. Some of them you'll find are behind a pay portal, depending on who the vendor is. Some of them you can Google and usually find fairly easily. But essentially what we have in a MIB file is we're just defining all the different things that we're looking at here. What we're looking at here is the IF MIB. This is one of the most basic MIB files you'll see. This is the interface MIB. It was written by a gentleman at Cisco. It gives a base description of what it is, any revisions, and then down here it starts listing off all the elements of it. Now, the nice thing is you don't have to read all of this information here. I'm just going over this to help you understand the basic structure of what a MIB file is going to look like so that you know what to look for when you're having to search for them. Anyone who's ever worked with SNMP and MIB files will tell you half the battle is just finding the right MIB file you need. Unfortunately, there's not any good means of locating the correct one. It's kind of hit or miss sometimes. Some vendors are really good about helping you find the right MIB file, like Cisco. Other vendors, not so good. Other vendors might just have one single MIB file for their entire product lineup. So it really depends on what kind of device it is and what you're looking to get out of it. Now, with all that said and done, let's jump into PRTG and let's look at some of the basics in terms of how PRTG works with SNMP. So I've got my firewall device here, and as you can see, I've got some sensors on it already, and these are SNMP-based sensors, but I don't have one of my more basic SNMP sensors on here, and that's our SNMP traffic sensor. So I'm going to add that guy, and this will give you a good understanding as to how SNMP really works here. So when I search for this and when I click on SNMP traffic, right now, while it says preparing sensor settings, essentially what PRTG is doing is PRTG is reaching out to that device and it's performing what's called an SNMP walk. It's walking the device, basically asking it, what are your interfaces? Give me all your interfaces and then give me all the stats about your interfaces. Is it connected? What speed is it running at? What type is it? Is it a 64-bit interface, meaning do we have 64-bit counters or not? And then what's the description that's on it? When PRTG gets that information back, which you see was very, very fast, I've got it here. I can scroll through it. I can see what's going on. I can filter for different things, so I know that if I'm looking for a particular interface, I can just type Ethernet, and it'll show me all the things with Ethernet in them. I could type in local and I'll just see that. The other nice thing with PRTG is that we do have the option to select all connected interfaces or select all disconnected or deselect everything. But you'll see that I can select them all if I wanted to. In this case here though, let's just do Ethernet 0 and let's do, let's grab this QS packet scheduler. Now, when we talk about additional channels, this is one of the things I was talking about with SNMP v2c. You'll see that we can get errors in and out, discards in and out, unicast packets in and out, non-unicast packets in and out. multicast packets in and out, broadcast packets in and out. Mind you, those are 64-bit counters only, meaning that if I don't have 64-bit over here, I don't want to select those. And then unknown protocols. In this case here, I'm just going to grab errors and discards. For connection status handling, I can tell PRTG whether or not I want to get an alert if the interface goes into a certain state. So right now, by default, we ignore all disconnected states. Otherwise, if you're in a busy network, I think you know exactly what that would mean. You would never get a moment of peace from PRTG, because anytime a user undocked a laptop or turned off a desktop, you'd be getting an alert from an access layer switch saying the switch port's down. We can show an alarm when disconnected, but ignore when deactivated, meaning that as long as the interface is up, admin up, you would never get an alarm if somebody unplugs the end device or somebody's in the data center unplugging the port locally there. Or we can show an alarm for all disconnected states. Now, understand, it's kind of good to follow the Cisco structure of things in terms of core distribution access. I would ignore all disconnected states on my access layer, and then I would go with one of these two at distribution and core. Your important switches, those are switches that usually don't change a whole lot. You want to get some kind of notification if interfaces just start magically going down on those. Down here on the descriptions here, we can change them to say something different if we don't like the vernacular of traffic in traffic out or traffic total. So I'm going to go ahead and create this, and you'll see that what it does is it takes us back to the firewall, and it's going to create those two interfaces for us. It's going to occupy two sensors. And while we wait for them to come up, which another nice thing with SNMP is that you'll see it comes up very quickly. Compared to WMI or any other, all I have to do is come over here and click scan now a couple of times, and you'll see that the sensor, once it starts populating the channels and the graphs, just like that, it's up and running. And we're already reading data as well. I can put limits on these just like I do any other sensor. So if I want to get a limit established against traffic total or traffic in and out, errors or discards in and out, I can do that just like I would any other sensor. Couple of things to look out for when it comes to utilizing SNMP. You want to make sure, first of all, that your device is configured to use SNMP. Devices don't come out of the box pre-configured with SNMP enabled. It's a security feature that most companies or most vendors will do. You don't want to have SNMP on if there's no need for it. And some devices that are hardened, you won't want to run SNMP. You may run another protocol for monitoring. Make sure also that you have the right port selected. Now, by default, SNMP goes over ports 161 and 162. Now, ports 161 is for SNMP polling. Port 162 is for SNMP traps. If you haven't checked out our video on our SNMP trap receiver, I highly recommend that. SNMP traps go the other way. SNMP traps is when the device tells you when it has a problem rather than you polling the device. So that's really handy for certain devices that have a lot of different traps. Cisco devices are especially handy with their SNMP traps because they will tell you all kinds of different things, especially about their environment. So if you have a device that's in a non-ideal environment, an SNMP trap receiver sensor is a great sensor to have, because if you have a fan failure or a temperature condition occur, the trap message is usually a lot better to get because it'll fire off immediately rather than waiting on you to poll the device or things like that, especially if you have to use a longer polling interval on a device like that. One of the other things to do as well is make sure you have the right community string. So with version 1 and version 2C, the way we differentiate access to devices is with what's called a community string. This community string, the default one, is public in most cases. Sometimes I'll see people using a bit of a cryptic one, or just something as simple as, company_network. If you don't use version 3, you're not really gaining any security by making it cryptic, so it's really just up to you. Now, if we switch to version 3, you'll see that the community goes away, and now I've got options for authentication and encryption. This is what we talked about earlier with SNMP v3. Here's where I select my user and my password for that user. Here's where I go with encryption on how I want to encrypt the data, and then if I need a context name. Now, this is something that some devices want, other devices don't care about. So again, your mileage may vary depending on what kind of device you're looking to monitor and what kind of settings it has for SNMP v3. But the port and the timeout remain the same on all of them. In terms of using SNMP, that's pretty much it. Like we said, it's right there in the name, simple network monitoring protocol. As always, if you have any other questions about SNMP, if you have a device that you're trying to monitor through SNMP, please don't hesitate to reach out to us, support@pessler.com, and we'll talk to you guys in the next one. Thanks.
If you find this video helpful, feel free to like it and consider watching our other videos on our channel. If you still have questions, please contact support@pessler.com, and always feel free to comment for feedback or suggestions for other topics. Thank you.